involving circles, secants, tangents, chords, all that vocabulary you've already learned from circles. And here's another example that I'm going to show you. I'm going to start off by giving you the name of the theorem that I used to describe it. I see that I have obviously a diameter, and I know it's a diameter because it goes through the center of the circle, and I have a chord because it's a segment that hits a circle at 2 points. Because I see those two vocabulary words, I call this the diameter chord theorem. Depending on what textbook you have, on how you learned it, how it was taught to you, this could be a whole different name. I just choose to call it this because I see the diameter and the chord in the picture, and it helps me basically set up the problem. So here's what the diameter chord theorem tells you. If you have a diameter, which is this line right here, and if you have a chord, and if they intersect at 90-degree angle, or if they are perpendicular, here's what you get for free. This half and this half of the chord have to be equal. In other words, your chord gets bisected. So that means this segment must be congruent to this segment. That's all it says. The diameter chord theorem says that if you have a diameter and a chord that are perpendicular to each other, the chord gets bisected. So if the chord gets bisected, whatever value is here must also be here. So based on what problem is given to you, you can now set up the problem any way you want. So being that x is right here, they want us to find the hypotenuse of this right triangle. So what I'm going to do is I'm going to change the orientation of that triangle and just go ahead and label it accordingly. I see that one side is 3, another side is 5, and x would be my hypotenuse. And because it's a right triangle, I can solve that using the Pythagorean theorem. So let's substitute everything correctly into the Pythagorean theorem. Square these numbers. 25 plus 9. Take the square root of both sides. So x is equal to the square root of 34. You may need to continue to simplify that depending on how your teacher wants you to solve these problems. But I won't get into that. That's technically an answer, and this is how you would solve this problem using this theorem for any others that you come across in your geometry unit.